Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Reaction of cyclohexene with HOCl, halohydrin formation. HOCl adds to cyclohexene via an electrophilic addition mechanism. The electrophilic Cl+ from HOCl attacks the double bond to form a chloronium ion bridged intermediate. Water then attacks the more substituted carbon from the opposite phase, anti-addition. This gives trans-2-chlorocyclohexanol as product A, because the O and Cl add in an anti-fashion, trans relationship on the ring. Moving on to the next step. Reaction of trans-2-chlorocyclohexanol with NaOH H2O at 25 degrees Celsius. Under mild basic conditions, NaOH, H2O, 25 degrees Celsius, the alkoxide formed from the transchlorohydrin undergoes intramolecular SN2 reaction. The oxygen attacks the carbon bearing the chlorine from the back side, inversion, displacing Cl. Since the O and Cl are trans to each other in A, the intramolecular SN2 is geometrically favored and proceeds to give cyclohexene oxide, 1,2-epoxycyclohexane, as product B. The oxygen and chlorine are on opposite faces, so the backside attack by the alkoxide oxygen on the CCl bond proceeds readily to form the epoxide. And for the final step, options A and D CIS-2-chlorocyclohexanol would form if addition were SYN, but halohydrin formation is strictly anti, giving the trans isomer. So A cannot be CIS. Option B, if A were trans-2-chlorocyclohexanol and B were antidiol, that would require direct hydrolysis conditions, acidic or specific oxidative conditions, not mild NaOH H2O at 25 degrees Celsius, which favors epoxide formation via intramolecular displacement. Option C, A is equal to trans-2-chlorocyclohexanol, correct halohydrin stereochemistry, and B is equal to cyclohexene oxide, correct product of intramolecular SN2 under mild NaOH H2O. This is consistent with all mechanistic principles. Therefore, the correct answer is C. Therefore, the correct answer is option C.